One of the best questions that I get in any math class is, where is this used in the real world? Like, what types of problems can I expect to see when I'm older and out of high school and in the real world that involves this type of math that we're learning right now? And what's super cool is if you go into any type of population modeling, whether that's for animals or for people, this type of math is used all the time when it comes to predictive modeling for populations, which basically means saying, in the future, I want to estimate how many of one specific either people or animal or plant will be in this setting in the future. That's essentially what we're going to be using. So let's look at solving a real world problem that involves solving equations with rational exponents. So let's say there's a population of squirrels, which will be represented by S for squirrel, in the park, and it's modeled by the function S, so the number of squirrels, is equal to 4 times 2 to the power t, where t is time in years, and S is the population of squirrels. So let's write that out. S equals squirrels, and t equals years. It represents time in years, but I'm just going to go ahead and cut out time and just call it years, because you know that time is a measure of years. So I want to know, what is the population of squirrels after 4 years? Okay, so we have our equation, and we're going to say the time that we're going to look at is 4 years. So what I'm going to do is I'm going to say t is equal to 4. Now, using this predictive equation that we have, right? We have this equation here. I'm going to plug in 4 for t and see what happens. So S is equal to 4 times 2 to the power, and then we're going to do 4 for t. So I'm going to go ahead and plug in a 4 right here. So now what you can do is take out Desmos and do 4 times 2 to the power of 4. We get 64. So going back, this is going to be equal to 64. So how many squirrels should we expect? We should expect 64 squirrels. It's a fun word to spell, squirrels. Okay, so using the equation that was presented with us, we were able to figure out how many squirrels would be in the future. But let's say, we don't necessarily want to know the number of squirrels in the future, but instead we want to know, how long is it going to take for there to be this many squirrels? So instead of given the number of years, we're given the number of squirrels. So instead of t being equal to 128 here, S is going to be equal to 128. So let's go ahead now and use this predictive equation again. So S is equal to 128. So 128 is equal to 4 times 2 to the power t. So I want to know how many years is it going to take. So this t, I want to figure out what that's going to be equal to. So here I just need to solve for t. I need to get rid of the times 4. Remember, the way that we do that in solving equations is division. So divide by 4. Again, if you're unsure about things, always use a calculator. So 128 divided by 4 gives me 32. I know 32 is equal to 2 to the power t. And here it's just solving an equation like we were doing in 1D, right? I want to rewrite this so they have the same base, right? It's kind of flipped. You're probably used to seeing it the other way, right? You're probably used to seeing it as 2t equals 32. But that doesn't matter, right? You could write it whichever way that you want. So let's look at powers of 2. So 2 to the power 2 is 4. 3. There we go. So we get 2t equals 2 to the power 5. Therefore, t is equal to 5. It'll take 5 years for there to be 128 squirrels.